Okay, is it okay? It started. Next part, we're away circle equation, and this is a very useful equation as a matter of fact, and you do have to remember that though, unless you want to remember the proof itself, and the proof itself is basically using distance formula. These things actually looks exactly like the distance formula. Distance formula, you have a d square is equal to x minus something square plus y minus another thing square. So if you can remember the distance formula, you can somehow remember the circle formula or the circle equation itself. And have to remember this. So basically this equation is telling you a couple of things. Radius is way over here. So that will be the distance between the center to, let's say, the edge of your circle. So that is going to be your radius. R is way over there. And then h and k is the variable that you do have to be careful about. H is the x coordinate because it goes with the x, isn't it? So it's the x coordinate of your center, while k is the y coordinate of your center. Alright, so this formula basically you need a couple things, and I'll talk about it on the next slide. While I was talking about this or using teaching you how to do this, a lot of people get really confused about what we're going to do with the x and y. Now, if you remember what it means by equation, equation basically you have some sort of variable in there, whether it's x, whether it's y, whether it's z, you gotta have something in there. So when they talk about a circle equation, if you know your center and you know your radius, you're replacing some of this item into a number. So r square is going to change, h is going to change, k is going to change. The rest of them actually just kind of stay there. X minus h square, y minus k square. The 3 in red will change to a number, and so you ended up with an equation. So I will just give you some random number over here. Let's just use this. The radius is going to be 1, 2, 3. It's going to be 3. 3 square is going to be 9. X minus, my h is going to be 2. And my y is going to be 2 again. If they ask you to find out the equation for a circle, basically this is it. You don't have to do anything more. There's nothing you are going to do about the x and y. We may come into another scenario later on that we will have to do something about the x and y, but if they just ask you for the equation of the circle, that's all you need to do. Finding your center, finding your radius, plug them in accordingly using circle equation, that's done. Basically, that's all there is. Just like I said before, to use the circle equation, you'll need two things, namely the center itself, the x and y coordinates, and the radius. Okay, and of course, not everything is that simple. Like this diagram is extremely simple because you can actually see the radius. I can actually count. That's what I was doing. I was counting the boxes. However, sometimes it's not as simple. They may give you a diagram that looks kind of like this. Of course, the center itself is not going to be too bad. You still can get that 2 and 1 right over there. So the h and k is right over there. However, the radius is a little bit different. The radius, I cannot count these boxes. You may try, but what I will need to do is I have to somehow find the distance over here. So it's 4, -1. So just apply your distance formula to find the radius. Okay, so I'll do that. I want to find the radius, so it's going to be r square. The difference between 2 and 4 is going to be 2. The difference between 1 and -1 is going to be 2 again. So r square is going to be 8. Right over there, 8. I would normally keep the r square because I know that my circle equation, if you do not remember, Circle equation actually uses R square on its own, so it's really no point to do the square root over there because I'm going to reuse that variable as R square. So using the circle equation, I'll write this out one more time. R square is going to be x minus h square plus y minus k square. So in this scenario, R square is going to be x minus, my h value is going to be 2, y minus my k value is going to be 1. There you go. So that will give you your circle formula. Okay, and I know we started with the diagram, and I want to tell you why this is actually very useful. Now, if you actually get yourself a circle formula in the beginning, you can draw this out right away. You can go onto decimals and plug that in. I know I used algebra over here, but let's pick decimals this time. I plug this in. X is equal to x minus 2 to the power of 2 plus y minus 1 to the power of 2. There you go. You get yourself a circle. So you can actually graph it on any graphing software. You can plug in your graphing calculator. So that gives you the graphic representation of it. Another thing that is, if you were not given the graph in the beginning, you were given this. You can quickly point that out. Oh, the center has to be 2 and 1. And the radius is going to be square root of x. So this is a very nice way to understand what an equation means. Once you get into algebra 2, there are lots of different equations. You want to spot the one that is useful. Okay, that actually means something. Okay, this one actually means it's going to be a formula for a circle. Okay, so under what circumstances you actually need those x and y is the key point for this video. Still not too bad. I think it's going to be okay. I just clone this from the previous whatever we did earlier. I got myself this equation. I can erase this. Now sometimes they may say, is the point, let's say, just pick a point over here. Is the point, let's do this point, 0, 2. Is 0, 2 on the circle? That means it's actually on the circumference itself. So they may say, well, test 0, 2. Of course, if you have the diagram, you know that it's not going to be on the circle, it's going to be within the circle. So what you can do is, without the diagram, you're going to plug the x and y in there. So that's when you need to use the x and y. So you created this equation first, and if you are going to test if a point is within, on the circle, or outside of the circle, that's when you need to use this point. So let's plug that in. I want to see that if after plugging in the x and y, I'm going to get x on the left hand side. So you have 0 minus 2, 2 minus 1, negative 2 square is going to be 4, always positive. 2 minus 1 square, 1 square is 2, 1. So it's 5, because 8 does not equal to 5. This statement doesn't make sense. Therefore, 0, 2 is not on the circle. Okay, it's not on the circle. And then another question may say, well, let's test 0 and 3 and see if it works. 0 and 3, just use red for it. 0 minus 2 is going to be 2 square, 4. 3 minus 1 is going to be 2. 2 square is going to be 4 again. 4 plus 4 is x. So yeah, x is equal to x. Therefore, 0, 3 is going to be on the circle. Alright. Now, Another thing I vaguely talk about, which the book didn't really talk about it though, is to test if a point is within a circle or not. Now, this test that we just did over here, testing the 0, 2, this test can only give me the information as in if it is on the circle or not, but it didn't really give me too much information about whether it's inside or outside. All I know is it's not on the circumference. So if you are going to do within or outside of the circle, what you will need to do is you want to test the distance. Okay, so I should be able to find the distance because I have all the points 0, 2 and 2, 1. I should be able to find the distance over here. You're going to compare that with your radius. Okay, you're going to compare that with your radius. If your distance is shorter than your radius, okay, my radius is going to be square root of r is equal to square root of 8. Okay, not the nicest number out there. And I'm going to find this distance. I will find this distance with green. 0, 2 and 2, 1. 0, 2 and 2, 1. I'm going to find the distance, so d square is going to be the difference of that is 2 square. Difference of that is 1 square. 5. So d is going to be square root of 5, right? So this bit turned into square root of 5. That is an odd looking square root of 5. So obviously square root of 5 is less than square root of 8 because they're both square rooting, and 5 is less than 8. Therefore, this point 0 and 2 is going to be within the circle. Now, of course, you may be saying that, why are we doing this? We have the diagram over there. I can definitely see that it's within. But most of the time, they are not going to give you this diagram. And that's why. They may ask you to test another points and, test a point over here, 4, 4. Let's do that. Why not? 4, 4. I will find the distance. 4, 4. And 2, 1. That shouldn't be too bad. We know that we're going to have a square root. That is going to be 2 square plus the difference between that is 3 square. 4 plus 9 is going to be 13. So if we're talking about that point is square root of 13. The distance is square root of 13 compared to our radius, which is square root of 8. Obviously, it's outside. So basically that sum up what we did with the circle equation. In fact, I don't think the book talk about the within and outside that much. They actually talk about if it's on the circle. So on the circle, you really do use your circle equation and plug the number in there. But I think the technique for finding the within and outside is more useful because you can actually do the same thing for the on the circumference, because if you find a distance that you have the same distance as your radius, then you have the same thing. So you don't have to remember two separate ideas. So it's up to you. The book didn't really talk about it, but I thought it would be nice to, at least for you to realize this is what you can do with your distance formula. It's so useful. Hopefully by now you can see that we are using the distance formula basically everywhere. And again, distance formula actually is your Pythagoras theorem. So it's such a powerful technique. Okay, that's done for now. So see you next week.